Let's continue with the testing of our traffic signal class. The last video, we looked at how to test a query method, light, and constructor, or how to set up those methods and make sure they work. This time we will test the command change. So this change is a method that we're going to have. And so before we actually make the change, create the change method in traffic signal, we'll set up the test. So here's how you do it. So we need to build a test for the command change. So, and maybe we have to figure out exactly what we're going to do with it. We're going to maybe change the signal 3 times and see the light cycle from green to I guess it'll be yellow, and then black, and then to red, and then after the third change, go all the way back to green. So we will change the light 3 times. Starts out with green. Remember, that's what we decided to make our, there it is. We decided to make our constructor for traffic signal set the light to green first. So without doing anything, we test the initial state, it should be green. And then we, in test change, what we'd want to do is, so that's going to be our method to test the change method. We're going to change it from green once, change it once, make it yellow, change it another time, make it red, change it a third time, make it go back to green. Ideally, that's what will happen. So we put this test in its own method, and we call it from the run test method, which is where all the tests start. So remember, let's go back again. What we will have is a run test method, which initially just tests the initial state, which is a private method. And so now what we will do is set up a new private method, which is test change, and that's going to get called from run test. Alright, so here it is. Here's our private test change method, and what we do is we call light to get the current state of the signal, change it once, and then print it out, change it again, print it out, change it a third time, and print it out. So ideally, initially when we start, it'll be green, it'll go to yellow, red, and then all the way back to green. Hopefully that's what will happen. You compile it and test it, and it says testing initial state 0. That's fine, probably, because assuming 0 is green, it's not the best, but that's okay. Test change will print out 4 lines, and it's saying that it's just 0. Well, why is it just not doing anything? Because remember, we haven't actually set up this method yet. It is stubbed, that is, it's like a do nothing method or a skeleton method or a stubbed method. Let me just go back all the way back to when we created the traffic signal class. Here it is. The change method is left blank, and now that we've written the test, now we're all ready to actually put some code into change. So what do? We have to change the light data member, whatever it is. You want to add 1. But if you just add 1, that's not good, because if it's every time you change, it'll just increase the value in light, and it'll go from 0 to 1 to 2, and then 3 has no meaning really. You really want it to go, instead of going to 3, it should go back to 0. Well, there's a nice handy way of doing that, and the answer to how to do that is not just light plus 1, but light plus 1 modulo, or remainder 3. What this does is, if light is 0, it goes light plus 1 is 1, 1 mod 3 is 1. Bump it up again, 2 mod 3 is just 2. 3 mod 3, however, so the third time you call change, 3 mod 3 is 0. So that's going back from red, which is 2, all the way back to 0, which is green, which is what traffic lights do. Okay, so that makes sense. So if you recompile this program as is described here, everything should work. Okay, so what do we have now? We have a simple test system for this traffic signal class. We also created 2 other classes, traffic signal test, which is not gonna, let's say, ship with our final product. Our final product is just gonna control, let's say, a traffic signal, actual real-life traffic signal, and the test is not that important. That's just for our own purposes to make sure that it works. This works. So we can modify this existing implementation. We can add new tests to the system. We can have, existing tests will help ensure that additions or modifications don't break implementation. And actually, these are the kinds of tests that people actually do. A lot of times, you might modify things ever so slightly, and that might break something that already worked. So and we set up these tests called regression tests to make sure that we are not regressing. We are always progressing or going forward. So we have existing tests to make sure that additions don't break what's already there. Okay, so now this final set of slides, I'm going to talk about static methods. So these methods are not dependent on the state of an object. Remember that static methods, the rule is static methods can only access static data members and other static methods. So methods not dependent on the state of an object. As the book describes it, static variables, static data members are not part of the state. And if you have methods that are not dependent on the state of an object, you can make them static. Okay, associated with the class rather than with the instance of the class. So static methods go with the class as a whole. They're always there for a class, and you don't have to have an object to use static methods. So they're not associated with objects or instances of the class. You've already used this, I'm guessing. There's a predefined class called math, and all of the math methods are static. So for example, it's the square root method, which takes a double as a parameter, returns a double. That's a static method. Then there's sine and cosine and absolute value. All of those methods in the math class, Java-lang math, they are all static. How do you invoke it? You just say, here's how you would use it. You'd say class name, which is math dot square root of a. You could, if you really wanted to, you could create an instance of the math class and call, let's say math x is equal to new math. You don't really have to do that, but say you did. Then you could say x dot square root a. It will just do exactly the same thing. So if you were writing the diagonal method for a rectangle, you would compute the hypotenuse, that is length squared plus width squared, square root of all of that, and this is how you would use it. You'd compute the sum of the squares and then pass that into the square root function, square root method, and that would return a double. Okay, so once again, static methods are invoked by prefixing the name of the class rather than the name of a class instance. You can use the class instance, but there's really no reason to do that. And actually, you'll get a warning saying that it's a static method. You should be referring to it like this, name of the class dot method. Okay, so if you have final features, that is final data members, any kind of named constants like that, you can, it's always a possibility to make them static final, and sometimes, and often I guess I would say, make them public too, because since they're final, they cannot be overwritten, so you could make them public. The specification static implies that the feature is associated with the class and not with the instance of the class. So you don't need an instance of the class to have this variable available. It's if you have the class name, you can say class name dot green, and that's there. It's available. Final means that the value to which the identifier is bound cannot be changed. You cannot change green to anything other than 0. And so remember, when you have a static data member, you want to use the class name, not an object name, dot data member. You can import the math.square-root method as a static feature. You can do that. Let's just say import static math.square-root, and from then on, The advantage of doing that is that you can just call square root without calling math.square root. So if you like to have, if this code looks better to you, you might want to do an import static math.square root. Same way with this new class that we're just setting up, you can import as a static feature traffic signal.green, and then you can just say light is equal to green. Makes our code look probably a little bit better. And one last thing I want to talk about is that this, although I don't recommend it all the time, sometimes it does come in handy. We can use the wildcard character to import all of the static features of a class. So you could say import static math.star, which says, this is a wildcard, says everything in math should be imported. So sine, cosine, absolute value, square root, there's a ton of other functions that I can't remember. Those are all now, they can all be used like you used square root. You can say sine, cosine, anywhere you want. You don't have to say math.sine anymore. And you can do the same thing with this class that we just set up. Let's say it has a bunch of static data members. We can import all of them so that we can use them like this without saying traffic signal.green. Just say light is equal to green. That's it. So it's a nice new feature that's available in most recent versions of Java. Okay, stop here.